Hey everybody, it's Ms. Bell here from the Science Lab, and with my video today I'm going to be focusing on the solar system and all of our planets that are found in the solar system. I'm also going to be talking about some other celestial objects, ooh la la, in our solar system or found in space, such as comets or asteroids, but I'll get to that later. You guys ready? You guys ready? Here we go! Do you know how big space is? I know I don't, and a lot of scientists don't know as well, because space is humongous. The universe is gigantic, so big that we don't really have the technology to really go out there and explore. But astronomers and scientists do know certain things about space that are somewhat close to us, especially about our solar system, our planets, even our own galaxy. Now you might ask, Ms. Bell, what is a galaxy? Well, a galaxy is a collection of gas, dust, stars, and solar system. And we have a galaxy that we are a part of, and that is known as the Milky Way galaxy. As you can see, our galaxy looks like this, but other galaxies have different looks. They might be elliptical, they might be kind of irregular shapes, but ours looks like this kind of starburst. So our solar system is located in the Milky Way galaxy. And all of these things, all the gas, the dust, the stars, the planets in our galaxy are held together by gravity, which is so cool. If you look at this, we are right here, planet Earth. And even my dot is really big because our solar system is so small inside our galaxy. So we have Swift Elementary, our school, inside Arlington, that's our city, inside Texas, that's our state, inside the United States, that's our country, inside North America, that's our continent, inside Earth, that's our planet, inside the solar system that has all of our planets, inside our galaxy, the Milky Way galaxy, and then our galaxy is in even bigger groups out there in the universe. And I'm telling you, space is gigantic, enormous, but it's so cool to learn about. And our solar system consists of planets and a star. The star is in the center. That is our sun. And all of our planets go around the sun. Now we have 8, count them, 8 different planets. They are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And all of those planets orbit around the sun, kind of like how I was pointing with my chair and going around and around. And there are different distances from the sun to the planet depending on where they are located in our solar system. Now, if you have trouble remembering the 8 names of our planets or even what order they're in, there's a very helpful acronym that can help you. Let's look at it. As you can see, my first letters are orange. MVEMJSUN. Those are the names of our planets. Let me tell you again. Mercury, Venus, Earth, and Mars. We got Jupiter, Saturn, Uranus, and Neptune. And this sentence is something that you can remember and help you remember the order of the planets. It goes, my very energetic mother just served us nachos. Let me say it again. My very energetic mother just served us nachos. You guys try. Ready? And go. My very energetic mother just served us nachos. Very good, very good. So our 8 planets can be divided into 2 groups, the inner planets and the outer planets. When talking about the inner planets, these are known as the rocky planets, also known as terrestrial planets. Now that's going to be our 4 planets closest to the sun. That's going to be Mercury, Venus, Earth, and Mars. And in our solar system, all 8 of our planets are kind of split into these 2 groups because there's a huge asteroid belt that goes, or that can be found in between the inner planets and the outer planets. Tons and tons of asteroids and rocks and meteoroids being that are orbiting around the sun but found in between these 2 groups of planets. Now, inner planets are going to rotate more slowly on their axis. So when they spin and spin and spin on themselves, it's going to go pretty slow. Also with inner planets, when you're talking about the moons that they may have, well, inner planets are going to have either 0 moons or very, very few moons, like maybe 1 or 2. Also, with the inner planets, none of these planets have rings that are found around the planet. And just like I mentioned, these inner planets are called rocky planets because their surfaces, their outer layer, are solid and rocky. Just like on Earth, we can step on Earth. We're not going to sink in. Just like on Mars, when we've sent space robots kind of to that planet, they were able to land on the planet because of its rocky surface. And when you compare the size of these inner planets to the outer planets, well, they're going to be a lot smaller in size. And last but not least, because they are closer to the sun, their pathways that go around and around the sun, well, they're going to be shorter in length. So it's going to take them less time to make a full orbit around the sun versus those outer planets. The last 4 planets in our solar system are considered the outer planets. We would call these the gas giants. I'm going to come back to that word giant in a little bit. But these last 4 planets are going to be Jupiter, Saturn, Uranus, and Neptune. Now, when I talked about that asteroid belt, well, these 4 outer planets are going to be found on the outside of that belt. And when these planets rotate on their axis, it's actually going to go really quickly, fast, which is the opposite of the inner planets. And these outer planets have lots and lots of moons. It might be in the 20s, it might be all the way up in the 60s to 70s. Tons and tons of moons orbiting around these 4 planets. And all 4 of these planets have rings. Some rings might be massive, like the rings on Saturn, or some of these planets' rings might be a little not as big or not as dominant. But all 4 planets do have rings, and these rings are made out of rock, ice, and dust. Now, these planets are called gas giants because, well, they're all made out of gas. They do not have a solid surface. Most of these planets are made out of hydrogen and helium, which are 2 types of gases, but the last 2 planets in our solar system, Uranus and Neptune, are actually made out of methane. That's where they get that blue color. And these outer planets are huge, huge in size when compared to those 4 inner planets. And lastly, because of being so far away from the sun, their orbital pathway is much, much larger and much longer. It's going to take them that much more time to make that full revolution going around the sun. Next up, I'm going to take the 4 inner planets and the 4 outer planets to make a total of all 8 planets, and I'm going to draw their orbital pathways with chalk on the cement. Now, I'm doing this at our school right outside the gym, and it's very simple to do. It just takes a lot of motivation and some time to complete this fun activity. So the first thing I know is our sun is in the center of our solar system. So I have our sun in the center. Then I'm going to measure with my meter stick and some string the length of each of our 8 planets and how far away they are from the sun. Now, this is to scale. Of course, our planets are not this close to the sun, but if we take these measurements and we make them larger, 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 bigger, 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 we would be able to see our solar system out there in space. But we don't have that much space here at Swift, so I had to scale it down. With each of our planets, I'm going around the sun. I'm drawing a huge circle, and this is the pathway that all 8 of our planets are going to take. You can see me measuring with my meter stick how far away each planet is located, and I'm using a piece of string which is kind of tied to a heavy rock to also show the circle which that pathway moves. In math, we would call the outer part of these circles the circumference, and I know that's a big, big word, but I'm just taking the time to draw these circles with chalk all the way around. I'm also labeling each of our 8 planets with their names, and to show you how these orbital pathways are different with all 8 planets, I am taking my feet and walking around every single pathway, 1 foot in front of the other, to count my steps. And I'm marking the number of steps on a piece of paper. Now, I do have one goofy mess up on my paper, and I want you to try to get it or find it if you can. It's kind of funny, and I did it on purpose, I know, but I wanted you to have something to look for whenever you see me write down my steps. But you can see, as I move from the inner planets to the outer planets, the number of steps going around and around these orbital pathways is getting larger and larger and larger. Mercury, I started off only taking 34 steps around that circle. With Venus, I jumped to 38. And with our planet Earth, well, going around that pathway, Earth would only take me 43 steps. Next after that is Mars, and that took me 48 steps. Our fifth planet, Jupiter, took me 71 steps. Saturn took me, 99 steps. That's one step less than 100 steps to go around that pathway. Our seventh planet, Uranus, took me 164 steps. And I want you to try to guess how many steps it would take me to go around our final planet, Neptune. If we know the number of steps is getting larger and larger and larger as I keep going further out into our solar system, can you make a prediction on how many steps it would take me to go around Neptune's orbital pathway? What would you say your prediction is? Well, if you said exactly 226, ding, 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 you are correct. With my next activity, I want to incorporate art with science like I've been doing in a lot of my videos. So I'm going to take markers and water and do some really kind of fun things with them to create our 8 planets in the solar system. So all I'm going to need is coffee filters, markers, a Sharpie, some poster board, and a spray bottle full of water. You guys want to see kind of what I need? Yeah? Ready? Let's see what happens. What's happening to all that color from my markers? Well, science is what's happening. Ah! Our first planet is Mercury. This planet is the closest to the Sun, of course, and there are craters on the outside of Mercury. So many craters that it looks very similar to our Earth's moon. It is the smallest out of all 8 planets, and there are no moons that orbit around Mercury. Our second planet is Venus. This is the hottest out of all the planets and the brightest out of all 8 planets. So bright that it can be seen from Earth without using a telescope. But it's super poisonous because of that carbon dioxide atmosphere. And Venus also has no moons, just like Mercury. Our third planet from the Sun is Earth. That's the only planet with life. Most of our planet is covered in water, but we also have land that living organisms can live on. The atmosphere that surrounds Earth allows us to breathe, and we have one moon that orbits our planet. The fourth planet from the Sun is Mars, aka the red planet. Water, believe it or not, once flowed on this planet. There's lots of research that astronomers and scientists have found to make that claim. Now, Mars has the largest volcano in all of our solar system and the longest valley in all of the solar system. Most of Mars is covered by a rocky desert, and it has 2 moons that orbit around that planet. The 5th planet in our solar system is Jupiter, which is the largest. It is known for having the red spot, and this is just a huge huge, strong, windy storm. Now this storm has been going for years upon years upon years, almost like a hurricane on Earth, but way bigger and way stronger. Now Jupiter has over 70 moons that go around that planet. How crazy is that? The sixth planet from the Sun is Saturn. Saturn is known mostly for its rings because it has the largest rings out of all 4 of those outer planets. It is the second largest planet, but it is also the lightest. It is least dense out of all 8 of our planets. And believe it or not, it's actually the flattest. So it's not a perfect sphere. It's kind of like a squished ball. And Saturn, as of a couple of years ago, has been named the planet with the most moons. It used to be Jupiter, but now it's Saturn. Almost close to 80 moons orbit around Saturn. The 7th planet from the Sun is Uranus, and Uranus is quite unique. It's the only planet to rotate on its side. So the rings that go around Uranus, well, they're actually vertical, or they go up and down, not side to side or left to right or horizontal like the other 4 outer planets. Uranus is the coldest out of all 8 planets, opposite of Venus, which is the hottest. Uranus has 27 moons that go around it, and it's blue because of the methane gas in its atmosphere. Our last and final planet in our solar system is Neptune. Neptune has the strongest winds out of all planets. Of course, it's the furthest away, not including our dwarf planet, Pluto. There are 13 moons that go around Neptune, and Neptune is also kind of that bluish color because of methane gas in its atmosphere. Now, the surface gravity, on Neptune is very, very similar to Earth's gravity. And that, my friends, is all 8 of our planets in the solar system. Now, I know a lot of you young kiddos like making slime. So here I am making galaxy slime just for you. First, you're going to need to take some clear glue and add it to some sort of bowl or pan. Half a cup of that clear glue. Then you're going to add some water and stir, stir, stir together. Half a cup of water to be exact. Next, you're going to color your slime to make it look like whatever galaxy you want it to look like. I'm shooting for a purple, so I'm adding red and blue. Stir, stir, stir until all of this is fully incorporated. Now, push that over to the side and get another cup and add some warm water to the cup. After that, you're going to add borax, B-O-R-A-X, and add it to the water. And borax is a white powdery substance that you're adding to a liquid. So because you need to fully incorporate the powder into the liquid, you're going to have to stir, 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 and keep stirring, stirring, stirring until this solution is finally dissolved. From there, you're going to slowly add this borax solution to your glue mixture. And as soon as you start stirring with the spoon, you're going to see it's getting chunky and thick, which is really, really cool. You might have to start kneading it or squishing it with your hands, and that's a-okay. But don't forget to add some glitter. The glitter kind of represents all those stars and planets out there in your galaxy. So I'm using different colors and different shapes of glitter. And voila! you have galaxy slime. You can squish it and pull it and squeeze it and twist it as much as you want. Just have fun doing it. And that's what science is all about. So the next thing I want to talk about are asteroids, meteoroids, meteors, and meteorites. Now, an asteroid is a solid rocky body that orbits around the sun, and it might come into contact with other things in space. As it crashes into maybe planets, moons, other asteroids, small chunks of it break off, and that's where we get meteoroids. So this is just a smaller piece of this. And both an asteroid and a meteoroid are found on the outer areas of our atmosphere of our planet. Now, as a small meteoroid makes its way into our atmosphere, it is therefore called a meteor. So it has entered into our atmosphere, and as it enters, that friction like that kind of starts burning up this rock, and it might have like a glowing visible path. A lot of meteors don't make the journey. They kind of fizzle out and are pretty much dead halfway through the atmosphere. But some are lucky. Some make it all the way to Earth and survive that trip through our atmosphere. And when it comes in contact with our planet, we would call that a meteorite. So it has landed on our planet, on the surface, and it did not fully burn up or vaporize as its journey going through the atmosphere. So the meteorite is the same thing as a meteor or a meteoroid, but just a smaller version. So the last type of celestial object I want to talk about is a comet. Now, a comet is made out of dust and ice, and as it moves around in our solar system, it is also following its own orbital pathway. As it gets closer and closer to the sun, that heat energy affects the comet. It will start to warm up, and those materials are going to start to kind of boil off of it. So in the center, like, there would be a big chunk of ice, but as that ice and the dust start to have things happen to them, it's going to kind of create like a fuzzy material around it, and we would call that the coma. This cloud can be huge in size, but that's just all of that dust being heated and all of that ice being heated up and vaporized into gas. And as a comet gets closer and closer to the sun, it's going to create what we call a tail. So the solar winds from the sun are going to push all of that heated dust and that vaporized gas away from the comet itself, like that icy nucleus, and it's going to form what we call a tail, or a stream of all these gases being pushed away from the comet, and kind of it looks like the tails are being pushed away from the sun. So that's all I've got for you guys with my video today about the solar system and all of the planets in our solar system. Just remember, you can remember the order of the planets by remembering that acronym. My very energetic mother just served us nachos. Nom 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 nom. Thanks so much, guys. I had a blast. I hope you did too. Space is my favorite thing about science. I love it. Yay! I'll see y'all later. Bye!